each one looks like, and we're going to use that program to help us when we do it on the program, but also you have to be able to do it by hand as well. But MRAM, the one that we did yesterday, which one of these pictures is using the midpoint of each rectangle as the height of the rectangle? The middle one, because look at each rectangle. The height is determined by the midpoint of that rectangle of where it touches that curve. So this is MRAM. And as you can see, MRAM seems like the logical one to use if you want to try to get as accurate as possible, because it's like a little bit above and a little bit below. LRAM uses the left endpoint of each rectangle. So which one of the pictures is that? First one? This one? And as you can see, the height of each rectangle is the left endpoint. And on this graph, all of those rectangles are underneath the curve, which means this is definitely going to underestimate our graph. Something to think about, will LRAM always be under the curve? Something to think about. Is it always going to look like that? And so then this is RRAM, and again, notice where the height of the rectangles are coming from are the right endpoints. And so, although MRAM seems like the one that's the most accurate, probably, especially by hand, LRAM and RRAM is easier because you don't have to find the midpoints, right? Like, you're just using the left or the right value that you already have. And so, we're going to practice doing them all. Again, we're going to change the name eventually and talk about a left Riemann sum and right Riemann sum, which again is just the exact same thing, except for named after the guy that studied them. I put the pictures on there instead of me drawing them because my terrible drawing. Does that kind of make sense? The three choices. And notice that you're going to get a different answer for each one, but all of them are going to be a close approximation. And just like we talked about yesterday, the more rectangles we make, the closer approximation it'll be. So instead of having 5 rectangles, if we made it 10 rectangles, as the width gets smaller and smaller, the over or under part is going to get smaller and smaller. So you're going to get more accurate, which is where it's kind of nice to use the calculators, because instead of you having to do 50 rectangles, you can make the program do 50 rectangles and see like how close, what is the actual value that you would get to. And sometimes your calculator takes a really long time. If you put 500 rectangles in there, it does it, but it seems like it's broken, but you can see that little thing at the top, like where it's busy, that it's thinking. So we're going to do this one. I want to do it by hand first, and then we're going to do the calculators. So maybe while we're doing this by hand, I can get one to work. I think even last night I transferred RAM from the black one to the green one. Combining them, from transfer area to my green one. And maybe you black one. And so I don't know. So notice that this is a three-part problem, because we're going to compute LRAM, MRAM, and RRAM. If we want to draw the picture every time we can.
8th grade last name starting with A2R. Please report to the library.
If you don't need to draw a picture at all, that's okay too. I'm going to at least draw the graph one time. X squared from 0 to 3. So as you can see, this is why part of the test is with the calculator and part is without the calculator. Because I want you to be able to do both. I want you to be able to compute this without a calculator, and then also with the calculator, and that's to go for most students at rate. X squared is just a parabola. I'm just going to mark an eye up there, and I'm really not going to be super... Could have been a lot nicer and only made you do 3 rectangles, but and this is where we talked about yesterday of do I need to draw the whole graph out at if I don't have a calculator and have to type it in? You can. But really what you're looking for is the x-axis of what are my values, because the width of the rectangle is determined by the axis, and the height is determined by those x values that I plug into the function. So if I'm doing 6 subintervals, what's the width of all my rectangles? 1/2, because there's 3 in here right now, right? So if I broke each one of these in half, right, that would make my 6 rectangles. Let's just start with LRAM. So that means I'm going to use the left endpoint for each one of those rectangles, and I'm going to draw in this first one just so you can kind of see it by hand, and then we can decide if we want to draw all of them. But if I use the left endpoint of that first rectangle, which is 0 to 1/2, if I use the left endpoint is at 0, so do you agree that that first rectangle, like, where's the rectangle? What's the height 0? The second rectangle is going to be determined by the left endpoint, which is going to now be 1/2. That's going to be that. And then I'm just going to keep going on the left. So then at 1, let's move it like that. 3/2 would be my next height. 2 would be my next height. And 5/2 would be my next height. 3/4. Notice that 3 does not make a rectangle. 3 doesn't make the height of the rectangle. We're only using the left endpoints. And again, not a requirement that you have to draw that in, but I just want to show you for this first one. So again, for me, I think it makes sense. Yes, we're going to do the width times the height for each one of those. But since the width is always the same, what I like to do is the width is 1/2. I like to just pull that out front, so I only have 1/2 once. And then I do all my heights in there together, instead of doing 1/2 times this plus 1/2 times this. So I always pull that width out there for the thing. And then my height is determined by the y value for each of those left endpoints. So my left endpoints are 0, 1/2, 1, 3/2, 2, and 5/2. I'm not going to be using 3 as an endpoint because there is no left side that we have rectangle. And again, I'm going to show all of you. 0, because the height is determined. And notice there are 6 rectangles. We have 6 heights. So something very common is people just want to use every number down there and they use that 3. And if you actually count, you'll be like, oh, that's 7. I did something wrong. No, only since that's 6 rectangles. Again, if this was on a no calculator part of the test, if on the calculator part of the test, you're going to be able to do first. If it's on a no calculator part of the test, if you didn't want to compute that, it's really not that bad. But if you didn't want to compute it, you're a lot of things like that. You know, leave that in your answer because it's all numbers. But on homework right now, I want you to still compute it because you have to calculate it. That you do, right? 35 fourths, is that right? Why don't I just use calculator? And just kind of a little good review, if you haven't been using your graphing calculator as much as you should have been, remember that you can just hit math 1 and it will take your decimal to a fraction. So when I did all this, I got 55. Or that's the same as 6.875. Did you get that? So I can't do it because I took a calculator. Anyone else do this? Did you get that? want you to do it again for MRAM. And if you want to go ahead and do the R1, you can. But MRAM is what we should have done on our homework yesterday. So MRAM should be more accurate, but again, what's harder about MRAM is that you now have to use the midpoint. So if you want to draw the whole thing, you can. I think I left you on the next page. If you want, I think I left the one slide if you want to work clear. Not below it, but for me, when I'm doing MRAM or any of these, just like we did yesterday, this is what I'm going to do. I'm going to label my picture. These are my 6 rectangles. And now you have to go through and you have to find the midpoint of each one of those, and that's what you're going to use to find your height when you plug it in your function. And so, 1/4 is where you should start with that. I'm going
to eighth graders F through Z, where they report to the library. And any other eighth graders who have not yet been tested, anyone else that needs to be tested, please report to the library.
If you get MRAM done and you feel good about it and you want to try RRAM, the only difference between LRAM and RRAM is you're starting with the right point, 0. I got 8.9375. And then RAM. If you think about it, you kind of computed almost the whole thing already, right? Like if you didn't want to rework it all, LRAM and RRAM share everything but share the same height everywhere but that last one, right? So they're going to add one with height of 1/2, height of 1, height of 3/2, 2, 5/2, and 3. So it's just going to skip 0. So if we think about it, you just do that off, just a 0 in this case. So it would be 1/4 plus 1 plus 9/4 plus 4 plus 25/4. And then that last rectangle is now going to have a height of 3. And so that would give us, so you can really just, since the first one was 0 on that one, we're just trading off one for the other. Anyone have a question on where I'm getting these? Yes, right? The 1/4 would be the first rectangle now. Because on LRAM, 0 was the first rectangle. Like there wasn't, like the first rectangle was nothing. On RRAM, now your first rectangle starting at 1/2. Right, but at 1/2 there is a y value, right? It's just 1/4. I got 11.375, which you can see they're pretty different numbers. 6, almost 9, and a little over 11. But again, imagine if we change it to 50 rectangles, that the limit, the limit as the width of those rectangles is getting closer and closer to 0, all three of these values should be merging to the same value. And that's the idea that we're going to build off this whole semester, is this idea of what if the number of rectangles went to infinity, right? Like what if we just kept making rectangles until it was the exact curve? The width just kept getting smaller and smaller, which is where it's kind of cool to use the program. So, looking at the last slide there on the note, it says, use RAM to estimate the area of this function for the following subintervals, 10, 100, and 500. The idea is, if you can get them to be close to the same numbers, we're not approximating anymore. Like, we can say, it looks like the actual area under that curve is this number. And so sometimes you don't even need to go to 500. Like, when you do 100, it's already so close to the same value. So here's what we're going to do. We're going to do the RAM program first. And then if we have time today, we'll go to the area one. And if we don't have time, then I'll show you that one tomorrow. But the RAM one is the one that's going to give you the value. So first of all, you got to go to y equals, and you have to plug that equation in. So go to y equals, and under y1, type in 1 over x. If you forget to type your equation in, then whatever's up there will be what it runs the program for. Or if there's no equation up there, it'll say error, because it needs an equation up there to know what to do. All right? And then you're going to go to program. And it's under, it's already ready for you to do, and you have to go down and highlight RAM. And it should come up like program RAM on your screen, right? And you hit enter, and it asks you A equals, B equals. That's asking you from what interval, right? Like when you do it by hand, it says from 1 to 3 seconds or whatever. So A to B is your interval, which in this case, it says A to B. On a normal problem, it would just say from 1 to 3, and you know that that's A and B. So we just hit 1, and then it should ask you what B equals, and you hit 3. And it asks you how many subintervals, how many rectangles do you want to do. So let's just start with 10, and you hit enter, and it should give you left, midpoint, and right rectangles approximation for those. And so we can say, are getting pretty close, right? So let's do 100 and see how long it takes to do that. So we just have to go to program and run it again. So we just have to go back and do it. Same interval. Now we're just going to change the 7 intervals to 100. And mine paused even for a couple seconds on 10. So 100 is probably going to pause for a lot longer there. I'm going to take a break, do that problem. So mine works. 500 is going to take a long time. So we can decide who we do. And as you can see, I would never want to compute 100 rectangles by hand, but the calculator does it very quickly, and we can already see that it's getting close to, it looks like it's getting close to 1.1. And if you do 500, I think that they're going to be almost the exact same number. And so if you see a question that says use RAM to find the value for this, sometimes people get confused and they're like, well, do they want me to do LRAM, MRAM, or RRAM? If they say use the program, they're wanting you to pick enough subintervals that you can try to approximate the actual value of that. Yeah, what does the graph look like? That kind of goes back to my question of, is LRAM always going to underestimate? You graph 1 over x from 1 to 3, right? When we plug 1 in there, we get 1. When we plug 2 in there, we get 1 half. When we plug 3 in there, we get 1/3. So it kind of looks like this. So that graph is a decreasing graph, whereas the graphs that we did before were increasing. So to answer that question, does LRAM always underestimate and RRAM always overestimate? No, because it depends on if your graph is increasing. Because now if we pick left endpoint, right, if we just did right here, we did left endpoint. It's going to overestimate, and if you do right, it's going to underestimate. So it's all about what it's consistent. Here's the scale. Was it like 1 for 1? I'm just going to say. So we could say, based on this, it looks like the area is about 1.1. So, since we have some time, let's look at the graph one, and it's just kind of, I like the graph one. It still gives you the sums. If you're just looking for sums, I think RAM is more efficient. But if you want to kind of see, is it overestimating, is it underestimating, what it looks like, then we can do that. So let's do something more exciting than what let's do y equals 4x plus x squared. Alright, okay, just kidding. Let's change it to minus. And then on this one, it's going to show you the graph for the rectangle. If you don't want the graph, then you should use RAM. So it matters what you should change the windows. You can kind of see what you're looking for. So change our window. Let's change our window for our x. Let's go from -1 to 5. So your x min should be -1, and your x max should be 5. And for your y, let's go -1. And if you look at the graph, you should see that it looks. So now we're going to run the program area. The program area. And again, it's going to have to be 8 So, like again, you can use what they give you. And this one, we're going to do from 1 to 4. Our A is going to be 1. Our B is going to be 4. And, I don't know, we'll start small. So a length of 1 is on the right thing we have. So let's just type in 3. And if you hit enter, you go back to your graph, and it should make 3 rectangles. And you can see, because it changes from increasing to decreasing, so over below the graph. And if you hit enter again, it will give you the sum of those guys. And if you just hit enter, it goes to RRAM and MRAM and RRAM. So it gives you a graph each time, so you can kind of see it. And then you click all of it. And if you want to do it again, make more rectangles. Make like 10 rectangles, and you'll see that the rectangles get smaller. You'll see that the overestimate or under estimate is getting smaller as it goes there. You did like 100 rectangles. I haven't tried it. Like I got it. It's just like still in the whole time. Yeah, and so it's saying that you did 500 of these maps, which is where we're going with this, getting to the limit definition of what it means to find your answer. And so, but they're so small now that you can't really see what's happening as you do this. Yeah, but then you can't really see 100. And remember that our intervals started at 1, right? Because 0 to 4 would be the whole graph, right? And it goes really slow, right? Like it's like putting those rectangles in. And if you go through it, it should show you that the 3 should be so again, RAM gives you the same information that the area program does. And the area program kind of connects with that as well. So you have it to start running your calculators every day, start taking them home as well if you're thinking of calculators on. Not because it's programmed, but because you will be using them all. There will still be times that we're not using them, like on your homework today. I believe 5 and 6 are, you can use the program to check your work, but I want to see work for 5 and 6. I want you showing me, just like we did in our first example, of writing out the height of each one. And you can use your calculator to add it up if you want. But I don't want you just running the program and typing the answer in. And then I believe 9 and 12 are, 9 and 12 are using the program. So, and when we have a test, the calculator part will definitely have some stuff having you use the program. The no calculator stuff will have some ones with just like more rectangles or rectangles that I want you to use. Okay. of really cool programs in here that I hope to put in that I meant to do last year, but didn't get to doing it. So remind me, keep on me about it. Like to borrow my local program. It has like ours is so old that it's really easy. But this is really what it is. Like it just shows me. Well, the first one it did, like it actually told me what buttons to push, and then it told me like what to do when I did. But then the second one I did was just the program written out, like the area program. I just started here, and then just typed all that in, and those buttons I knew what they were. But you can't learn to like it sounds so there's really cool in here. Here to our board and what you can do in 3 hours. Yay! You only have to do one and then share. That's a cool idea. There we go. What if I reset to default? Does that delete my program? That's a default. If I just hit reset to the full RAM, I just hit default. I bought this at the art sale, and there's a set of programs on it like this that are archived, but when I tried to do something on it, instead of, yeah, so I used to archive the CPU. Oh, okay. But then if I want to clear all RAM, I can just archive it, and then
I just want to the office, please. I need Jeff Honeycutt, Salem Lawson, the office, please. I need Cheyenne Shoemaker to report to the guidance office.